Illumina next-generation sequencing has had a huge impact in our work, and the best recent example of that is a paper now published in the New England Journal of Medicine. We tackled a disease that affects thousands of children and adults called Sturge-Weber syndrome. This disease was described in the 1870s. It's neurocutaneous, so the skin and the brain are involved. Sometimes it involves seizures, intellectual disability, really tremendous problems. We did whole genome sequencing of paired samples, affected and unaffected regions of the same individual for just 3 pairs of individuals, and identified the gene which is mutated. From that, we could then do targeted sequencing on a MiSeq, looking at 90 samples, and we could do depth of sequencing up to 10,000-fold. And from this, we rigorously and convincingly showed that indeed we had found the one small mutation. So we really found a needle in a haystack. And this will transform our understanding of this disease. We now know the gene that causes it, we know the mechanism, and we even can begin work on treatment strategies right away. And so none of this would have happened without next-generation sequencing. As a community, who knew that each of us has 20,000 genes? And who knew that each of us has a couple hundred of them having loss-of-function variants? And so the landscape has shifted so dramatically. Now that we know this, we have an opportunity to focus in on which variants are of interest in each particular condition. If we look at rare diseases, cumulatively, there are 25 million Americans who have them, and so they're so common. With next-generation sequencing, and in particular with targeted sequencing panels, such as the autism one, I think it's possible to really make tremendous medical strides and start applying the potential of the technology to diagnosis, and our dream is to treatment. What's on the horizon for us is that we will increasingly use this as a tool on the clinical realm that includes dozens of clinics here at Kennedy Krieger Institute which really need to have a molecular diagnosis or genetic diagnosis of a condition. And from a purely research point of view, I'm especially interested in children with severe behavioral disorders. Now we have the prospect to take their DNA. We have informed consent from the families to do this and go characterize the genetic variation to try to help. My real passion is in helping the children who come into the Kennedy Krieger Institute. And in the case of Sturge-Weber syndrome, I have the most satisfying feeling in the world to be able to tell the parents and the children, and the people who are affected, this is the cause and this is what we can do to begin to treat and hopefully cure it. We're oriented towards what problem we need to solve clinically. And so I feel really excited by this technology in enabling this level of advance across different kinds of conditions.